Hello everyone, welcome to today's lecture. In our today's lecture, we are going to learn a second algorithm for finding the frequent item set, which is a FP growth algorithm. So this algorithm is an improvement to the a priori method. A frequent pattern is generated without the need of candidate generation. In our a priori algorithm, we are creating the candidate set. Yes, by analyzing the database. So here in the FP growth algorithm, we are not generating any candidate set, but without that set, we are creating the frequent item set. FP growth algorithm represents the database in the form of tree called a frequent pattern tree or a FP tree. So in this algorithm, we are just creating a tree, and the tree is called the frequent pattern or FP tree. So based on that tree, we can say that these are the frequent item set. This tree structure will maintain the association between the item sets. The database is fragmented using the one frequent item. This fragmented part is called the pattern fragment. This item set of these fragmented patterns are analyzed. Thus, this method and search of the frequent item set is reduced comparatively. So, here on this point, it is said that the frequent item sets are maintained, or the relationship between that item sets is maintained in the FP tree, and one frequent pattern is created, and based on that frequent pattern, we are creating the whole FP tree. Now the next is frequent pattern tree. Is a tree like a structure that is made with the initial item sets of database. The purpose of FP tree is to mine the most frequent pattern. Each node of the FP tree represents an item of item sets. So as per tree, the first is a root node. It is compulsory, and based on that root node, multiple nodes, subnodes are there. So that nodes represents the item sets. The root node represents null, while the lower node represents the item sets. The association of nodes with the lower nodes, that is the item sets with other item sets, are maintained while forming the tree. So here it is said that the association of nodes means the nodes which are repeated. So that nodes association is maintained while forming the tree. The frequent pattern growth method. Let us find the frequent pattern without candidate generation. So let us see the steps followed to mine the frequent pattern using the frequent pattern growth algorithm. So the first step is to scan the database to find the occurrence of the item sets in the database. This step is same as the first steps of a priori. The count of item sets in the database is called the support for frequency of one item set. So it is counted that if the item set is repeated 4 times, then the support is become the 4. The second step is to construct the FP tree. For this, create the root of the tree. The root is represented by null. The third step is to scan the database again and examine the transactions. Examine the first transaction and find out the item sets in it. The item sets with max count is taken at top. The next item set with the lower count and so on is taken as lower. It means that the branch of the tree is constructed with the transaction item sets in descending order of count. So the highest count is at the top of the tree. The next transaction in the database is examined. The next item sets are ordered in descending order of count. So if any item sets of the transaction is already present in the branch, for example, the first transaction contained 2 values, suppose A and B, and the second transaction B is already repeated. So in that situation, transaction branch should share a common prefix of the root. So we are not creating the new node, but we are just attaching that node, or we can say that if it is in the same branch, then we are increasing the count, and if it is not in the same branch, then we are creating new node, and then we are attach that node to the old node. So this means that the common item set is linked to the new node of another item set in the transactions. Also, the count of item set is increased as it occurs in the transactions. Both the common node and new node count is increased by 1 as they are created and linked according to the transaction. So the count of the item set is incremented by 1 if it is repeated one time. So if the one item is repeated 4 times, so at the end the count is become the 4. The next step is to mine the created FP tree. For this, the lowest node is examined first along with the link of the lowest node. The lowest node represents the frequency pattern length 1. From this, traverse the path in FP tree. So this path or paths are called conditional pattern based, and conditional pattern based is a sub database consisting of prefix paths in FP tree occurring with the lowest node. So this is after FP tree, the last step is for mining the frequent patterns is called the conditional pattern base. Construct a conditional FP tree which is formed by a count of item sets in the path. So the item sets meeting the threshold supports are considered in the conditional FP tree, and frequent patterns are generated from the conditional FP tree. So these are the steps. So by using these steps, we can generate the frequent pattern set, and based on that we can generate the FP tree and conditional FP tree. So let's understand it with the example. So let's understand FP tree with the example. So this is the transaction data that is already given in the question. Also the minimum support value is also given in the equation. So here minimum support is equals to 3. So this is the value that is already given in the question. Now the step 1 for the FP tree is the same as the a priori algorithm. So the step 1 is find the minimum support of each item. So we'll write each and every item in unique order and find the support of each item. To find the support of each item, we'll just count the repetitive value of each item, and that repetition is become the support. Here is repeated 3 times in the transaction, that is why the support is 3. So same as we'll count the support for each and every item. So this is the first step, and the step 2 is also the same as a priori algorithm. So the step 2 is discard item with support less than minimum support 3. Here we know our minimum support is given 3, so we'll discard those items whose support is less than 3. So in this example, the item this D, E, G, H, I, J, K, L and H and O. So these are the items that whose support is less than 3. So we'll discard those items. So the remaining items are A, B, C, F and P, and these are the support of each items. So this is the second step. So this step is also the same as a priori algorithm. Now the next step is order all items in frequency dependency order. It means that now this order is very important. We have to sort this item into a descending order with the highest support. such that the item whose support is highest is the first, and then lower support items. So here support is 3. So here frequency pattern is become F, because F support is 4, so which is the highest, so 4 repeated 4 times. Second is C repeated also 4 times, so the second frequency is become C. Third frequency is A because the support is 3. Next is B because support is 3, and M and P. Yes, so our frequency pattern is become something like F, C, A, B, M, P. Okay, so these are the frequency pattern. It is very important for the further calculation. So this is an important step to find out the frequency pattern based on the support. Now the next step is, this is our if we does not count this box, so these are the equation that is given in the question. So these are the data that is given in the question. Yes, now we have to write these items in this frequency manner. So for that we'll take the first item set from frequency pattern, and if it is available in the item set, then we'll write into the ordered item set. So our frequency is FCABMP, so we have to write in this manner only. So first is F, it is available in first transaction. Yes, F is available, so I'll write F here. Second is C, so C is available in this transaction, so yes, C is available here, so I'll write C here. Next is A, we'll find that A is available in this transaction. If yes, A is available, so I'll write A here. Next is B, so B is not available in this transaction, so we'll not write here. Next is M, so M is also available, so we'll write M. And the last is P, and P is also available. So the first ordered item set is become F, C, A, and P. We are only considering those items who is belonging from the frequency pattern. So these are the frequent item set, first frequent item set. Second transaction is ABC, FL, MO. Now we'll sort that transaction based on the frequency. So first is F. F is present in this transaction. Yes, F is present, so I'll write F here. Next is C. C is also here, so I'll write C. Same A. So he is also in this transaction, so I'll write A here. Next is B. So B is also in this transaction, so I'll write B here. M is also in this transaction, and P. So P is not in this transaction, so we'll not write P here. That will analyze the third transaction. So the third transaction is BFHJO. So first letter is F. So F is also available in this transaction, so we'll write F here. Next is C. So C is not available. A is also not available. B is available, so we'll write B here. M and P is not available in this transaction, so we'll not write B here. Now same as in this transaction, BCKSP. So in this, F is not available, so we'll not write F here. Next is C. So C is available, so I'll write C here. And then A, if A is available, no, so A is so I'll not write A here. Then B, so B is available, yes, so we'll write B here. Next is M. So M is also not available in this transaction, so we'll not write here. And last is P. So P is available. So P is available, so we'll write P here. So our frequent item set is become CBP. We'll discard the item set who is not in the frequency set. Okay. Now next is AFCELPMN. So we'll match with the frequency pattern. F, yes, F is available. C C is also there, A is also there, B, no, B is not there, so we'll not write here. Next is M and P. So these are the final frequent item set that we have collected from the frequency pattern. Okay, so this is a very important step, because from this item set only we are creating the FP tree. So this is important. Now next step is to count the frequency items. So F is repeated 4 times, C is repeated 4 times, and other items is repeated 3 times. Okay, so this is a frequency count. Now the next step is, as I said, that FP tree is started with the root node. So in the first step we are creating the root node. Now we are just writing our frequency set here that we have calculated here. So our frequency is FCA, B, and P. So we'll write here F, C, A, B, M, P, and we'll okay. Now our first transaction is FCAMP. Okay, so the root is already available here. Okay, now the first transaction is F, so we'll create the node of F and write F equals to 1, because it is write the support of F in this transaction. So F is repeated 1 time, so support is 1 here. Now next C, so we'll again create a new node and write C equals to 1. We connect this node with this frequency item set, and F then C, so we'll also connect this F then C then A, so A equals to 1, and we'll connect with this A. Next is M, so next is M equals to 1, and we'll connect with this, and last is P, so P equals to 1, and we'll also connect this. So this is the first root, first branch of our FP tree. So this is a first branch, same as we are connecting this with the second transaction. So the first second transaction is F equals FCABM. So I am doing in the same tree, but in the examination you have to write each and every step individually. So here second transaction start with F, so we'll go with here root to F. Here the value of F count is 1. Now F is repeated 2 times, so here the value is updated and it become 2. Now F then C, so again go to C and update the value, then also A, so go to A and update the value of A, it becomes 2. Now the next item is B, but here B is not available, so we are creating the root B. We are creating a root B from root A, because the chain is FCABM. So from A I am creating a new node which is a B, and it is repeated 1 time. Yes, so B, and I just connect it with the frequency items at B. Okay, and the next item is M. So from B it become N, and I will update the value of M. So this is the second transaction. After second transaction the tree becomes something like that. The third transaction start with F, So also from root to f, update the value of f and it become 3. Next transaction is b, but b is not available here, so I will create root b from f, so b equals to 1. Now b is connected here, so I have to connect this root with this, so all b root is connected in the same line, so I will connect b with 1. Okay, so this transaction is completed. Now the third transaction is started with f. So from the fourth transaction is start with the c. So I will create a new node and name that node c equals to 1. This is repeated 1 times. Yes. Now we already have a c frequency node that we write here and connect with this c. So I have to connect this C node with the new created C node. So this is how the all C roots are connected. C then B. So B is also there. So I will write B equals to 1 and connect this B and this B with this new created B node. And last is P. So from B it is P. So P equals to 1 and P is already here, so I will connect it with P. Now the next and last transaction start with F. So the value of F is become 4. Then C, so value of C is become 3. Then A, so A is again repeated, so value become 3. Then M, so here is M, so value is also become 3, and then P, so the P count is become 2. So after all this transaction is updated on this tree, so this is called FP tree. Yes, so here we can see that we have to match this count with this already created count. Here F is the support of F is 4. 4 is repeated 4 times. So now here we'll check the value of F is become 4. Yes, so then it is right. Next is C equals to 4. So here the value of this root node is 3 and this is also connected with this node. It becomes 1. So 3 plus 1 equals to 4. So this is also right. Now A equals to 3. Here the count of A equals to 3. Yes. So this is also right. Now M equals to 3. So sorry, here one new B equals to 3. Now the B equals to 1. 1 is connected here 1 and this one is connected here 1. So B is repeated 3 times. So this is also true. Next M equals to 3. So M equals to 3, then it is right, and P equals to 3. So P equals to 2 and 1. 2 plus 1, 3. So then it is also right. So this is how we can verify our FP tree. So this is how we have to create our FP tree. So now the next step is to create the conditional FP tree. So for that, so this is our final FP tree. Yes. So for that, first we have to write our frequency pattern here. So FCA BMP. Now we have to write this frequency pattern into the reverse order. So first is P, M, B, A, C, F. So this is the reverse order. And now for the conditional pattern base, I have to write the path for the I have to write the path to reach the P node. So to reach the P node we have two main paths. First path is F, C, A, M, P. So okay, and the second path is C, B, and will reach to the node P. So we are writing this path here. So we'll write it like in the curly braces and the curly braces, the first path is F C E M, and at that, and by using this path at the end, the support of P is 2, so we are writing the support 2. Okay, and the second path is C and B, and at the end support is 1, so we'll write support here 1. So this is how the conditional pattern base is counted for M. Now to reach M, the first path is FCAM. Yes, and second path is FCABM. So we'll write and the second path is FCABM. Yes, and the support is FCABM 2 and 1. So here you'll write support 2 and 1. Same for B. To reach the B, the path is 3. First is FCAB, second is FCB, and third is the third is C and B. Yes, so we are writing here okay. Now for A, the path is F and C, and at the end support is 3. For C, there is only one root, which is directly F and C. First is directly a root, and the second is F and C. So here we are writing this path F, and the support is 3. And for F, there is no path because it is directly connected with the root, so we'll write here empty. Okay, now this is the conditional pattern based, but for mining the FP tree, we need to create the conditional FP tree. So here we are creating the conditional FP tree for P, so we are writing P here, and then on the curly braces, the conditional tree is written like which item is repeated in all these roots. So here we can see that only C is repeated here, so I'll write C, and support is 2 plus 1, 3. Same as in this transaction, F is repeated, C is repeated, A is also repeated, and M is repeated. Yes, so F colon support 2 plus 1, 3, C3, A3, and this is counted for M. Same as in this transaction, it is repeated F, so F is repeated into we have to write the path which is repeated in each and every transaction. So here F is repeated in 2 times but not in this. C is repeated 2 times but not in this. So in this nothing is repeated, so we are writing as empty. Next is FC 3, so it is written as F3 comma C3. In F3 it is directly written as F colon 3, and at last it is a empty. It is for C and it is for A. Okay, so this is how the conditional FP tree is generated. We are just first creating the conditional pattern based on the path of the FP tree. After that, we are creating the conditional FP tree, and for that we are just choosing those item set who is repeated in each and every roots and with their support. So this is how the conditional FP tree is counted. So this is how the conditional FP tree is calculated. Thank you.